Good morning, everyone. Welcome to StruSoft BIM Day. During these upcoming 3 hours, we will present the flow of information for a concrete prefabrication building from an architectural model to the construction site. And we do that via Revit, Fem Design, Dynamo scripting, impact design, and finally impact production. The attending specialist from StruSoft will guide you through the process. Hopefully will give you a good understanding of the possibilities using StruSoft and Autodesk software. I want to mention the newest team in StruSoft, the parametric group represented by Andreas Oskarsson, that makes the BIM communication work smoothly. I also want to give a special thanks to Ivari Sume in AutoCAD for helping us organizing this event. The agenda allows you to participate for your special interest, but for the best user experience, I recommend you to stay online for the complete session. After the product presentations by StruSoft, I'm happy to welcome 2 customers, PCC Project and TMB Element from Estonia, presenting a real user experience. Who is StruSoft and what do we do? In short, a present staff of 140 people divided in 9 countries are focusing in giving the best user experience for any product or service that StruSoft delivers. And this is done by local representation. We have experts in the field we work, structural engineering, concrete prefab, energy simulation, and computing science. Good support, implementation, and trainings are the key factors for our customers. During the last 10 years, StruSoft have started expanding outside Sweden. Expansion, new markets, and new customer will give new demands and help us to continuously develop a better product. Milestones in StruSoft history. The history is important for creating the future. One recent important milestone is in 2019, when Vind, a Norwegian industrial owner, acquires the majority of StruSoft. This acquisition wouldn't be possible if we haven't succeeded in the past. So history counts. I quote Harald Hög, CEO and owner of Vind. StruSoft is attractively positioned as the market leader in the Nordic. The aim of StruSoft is to widen its geographical coverage and launch new products. StruSoft originates from the technical department in Skanska, and in 1982 started the adventure in a cooperation with Arup in UK, and the software package that will be the foundation for Winstatic. And in 1991 started the development of Impact as a cooperation with Skanska Prefab. And during these upcoming 10 years, Skanska Prefab will be an important partner in the Impact platform. In 1997, after 3 years of developing Fem Design, we founded Skanska KFT in Hungary. This speeded up the development from a 2D plate design to a real 3D model. And in 2002, we were 13 people that left Skanska and started StruSoft, and the rest is history. I've been talking a lot about user experience and development, and this slide shows some moments from our yearly customer event. For Fem Design and Impact, we invite the key customers to meet the developers and contribute to the future success. As you see, we now are in the active StruSoft region. This is a Nordic and Baltic region. And you can also see that we have started to plot our red dots in new and different places. The future will be a fun ride for us all. Okay, thank you very much. This is a short presentation of StruSoft. And I hand over to Cyprian to talk more about the product we have.
Cyprian, we cannot hear you.
Oh, sorry.
Yes, okay.
I was talking to myself.
Yeah,
Thank you.
clearly.
Thank you.
No worries.
My name is Ciprian Țipea. I'm a technical expert for StruSoft and also handle sales activities in Romania and Baltic countries. And today I'm going to talk a little bit about our products, but mainly about our calculation softwares. I will leave the excitement and the journey of our BIM to be handled by our guys in the Impact team. All right, so in order to start with, I will talk briefly a little bit about Fem Design, about FreeStress, WinStatic, and I can give you a short description about WinStatic, which is our calculation, energy calculation software. So Fem Design, as you can see, collaborates with everyone in terms that we can import models from DVG or DXF. We can work with IFC models, and yeah, here you can, in the right part, you can see in the figure a physical model, the analysis model, and the result model of a building. Here we have another fine example of a staircase made yeah, with the help of importing a DVG drawing, of course. Then if we move to our Fem Design interface and modules, we can see that Fem Design is able to handle foundation design with the help of 3D soil, or without it, with the help of just our settlement calculator. We can use it for reinforced concrete design, for steel design, timber design, and composite design. We have our new CLT also, and masonry design, which were not included in this presentation. As you can see, Fem Design, as the title say, can do a lot. The cross-section analysis means that the displacements of a reinforced concrete plate, walls, columns, and beams can be calculated based on their crack state and design reinforcement. We can also do a simplistic approach now with the new feature of stiffness modifier introduced in our latest version of Fem Design 20, with the help of which we no longer need to go into the advanced crack analysis, but we can simulate it by using the stiffness modifier. Also, another, I might say, important feature is the ability to model beams and columns, which can be straight or arced, as shell elements in order to model more accurately for stability utilization checks against flexural, torsion, lateral torsional, and local buckling effects. In this slide, there is a brief presentation of the auto design of steel. Then here it's the auto design function of concrete. And lastly, the auto design of timber. As I said before, we have this 3D soil model, which is a little bit different in terms that it can model the soil as a 3D volumetric finite element, with the help of which we can examine more accurate how the building and the surrounding soil will be influenced by the external loads. As my colleague Mikkel van der Leur said, Fem Design is the development of Fem Design is driven by its users. Each year we have the users meeting in which basically we decide upon the features that will be developed next. And this is, of course, decided with the input and with the help of our users. Now, moving on to another software, FreeStress, which is our software used to calculate pre-stressed beams or plates with or without active reinforcement. Here I mainly wanted to introduce in the slide the steps that we will have to go through, or some of the important steps when using pre-stress, which is a really user-friendly software. And basically, in order to start the software, you define your own project, your own section of a beam or of a plate, and then you go through the first stage by defining the reinforcement positions, the calculation settings, loads, etc. Then in the figure below, I placed it as a load combination table, and also in both of them you can see the different stages that are analyzed during calculation, from release stage to storage, transport, and then all the way to final and fire stages. Then in the diagram, we can see the calculated efforts according to the imposed loads. And then the final step is basically to do a code check, a design check. And in each particular stage, we will have a detailed verifications for that particular stage. And if something goes wrong, as it was highlighted in red. So yeah, FreeStress is used due to its large applications and ease of use. So I encourage you, if you didn't yet, do so. Then we also have WinStatic, which is mainly an element design software. It is comprised of multiple modules, which can be frame analysis of concrete, steel, and wood. It can have beam, section analysis, column punching, retainer wall, masonry design, corbel design, and foundation and settlement. This is also a really intuitive and easy to use software. And basically, I encourage you to apply for a trial if you did not had contact before with any of our softwares. We will be gladly assisting you throughout the trial process. And if there are questions during the presentations, please use the questions field, and our colleagues will do their best to answer them as accurate and quickly as possible. Thank you very much. I will now hand over to my colleague Tyan for his presentation.
Good morning, everybody. I hope you can all hear and see me well. My name is Tyan. Most of you already know me. Good to see some new faces as well here. So I will be kicking off the BIM part of this session, and starting from what the title says. So going from Revit to Fem Design, and talking about Fem Design as well in the process. Luckily now I have more time than I anticipated, so it's good. I always talk more than I should. I have so many things to say about everything, but I try to keep it as informative and as an overview as possible, not going very deep into things. So my slideshow here consists of only one slide, because I will show everything you live, so I don't have any other things. I have no other slides, so just let's close the slideshow. Okay, so we start with the Revit. We start with Revit model, and the thing is that we already have, and let's say a preliminary or a preliminary model, I would say. The guys at Impact, they have made a great job, because this model already contains some elements. So somebody already made this model view, precast element model already, but it could be any model. It doesn't have to be this kind of model. It could be architectural model. It could be Revit's own structural model. It doesn't matter. We can use different models to get the information from. But the main thing here to keep in mind is that if we are transferring anything, let's say from Revit to Fem Design for the calculations, the main thing is that we have to keep in mind the analytical model. So I will show you what I mean. This is the analytical model. This is the thing that we want to transport from one software to the other. You can see it has its own limits, of course. It's only thin shells and bar elements, which consists of only one line basically. But those elements are the ones that carry on the information. So we have some information for those elements inside Revit, for example, or any other software. It's possible to do with other softwares as well. But these are the things that mainly go over to the calculation software, not this beautiful picture that you saw earlier. It's very nice one. We have all the details inside. We have I don't know, lifting hooks and recesses on hollow cores, But those things usually they are not converted when we are transferring information from one software to the other. So we talk about mainly the analytical model. And inside Fem Design, we have a tool that we built, a StruSoft add-in that's made specifically for transferring this analytical model to Fem Design software. But it could be used to prepare the model for other softwares as well. But now we are talking about the link with StruSoft software, so that means Fem Design. So the first things to check is, of course, to check if the analytical model is there, if we have all the materials applied, because otherwise the calculation software does not know what it is. We cannot transfer elements without materials, although it's kind of possible to have those elements inside Revit. It's not possible to do a calculation on an element which doesn't have material. So every software has its limitations, of course. And there are other things to check. For example, the connection status that you could check to see if elements are connected to each other, which apparently they are not. We don't, of course, have to keep in mind all the red dots. For example, here the window opening doesn't have to be connected to anything, but I'm pretty sure that those two walls should be connected. And also the beams, for example, they are just like hanging in the air. There's nothing supporting them. So those things have to be considered when we are transporting the models from one software to the other, because they will not be automatically taken care of. It's not possible to do that. Software is not the engineer. You are the engineer. You should do it. You should be able to control how it works. But we can export this model from Revit using our StruXML format. So I will just select the database so we know what we are up against. And basically you just fill in all the material mapping. You select the material inside Fem Design and you select the material that is corresponding in Fem Design. Sorry, this is in Revit and this is in Fem Design. So you have to map them together to be able to transfer the elements. Otherwise, the software does not know what the concrete precast in place gray is. I mean, this could be anything. This could be C2530, it could be C5060. You have to make the decision. So there are some human intervention needed. Of course, it's not automatic, but it's pretty easy to map those things. And of course, we have to do the same with the sections, the same way, like what is the lintel thing? Nobody knows exactly what it is. So we have to find the similar object in Fem Design's library to map it. I just put IPE 80 here because I don't have that section inside Fem Design yet. I could make it myself and then I could map it, but it's a very easy thing to do inside Fem Design also. I can search for all the IPs which are using the same section and I can easily switch them or swap them out. So I'm not worried about not getting the right sections right now. I can do that later as well. If you have mapped everything, then you just press export basically. So it's that easy. You get something called StruXML. So it's a middle format. It's not directly like tied into Fem Design. So Fem Design won't open up. You won't see the model directly. You will get the middle file, a transfer file, a StruXML file. So we use XML format to transfer the data from Revit to our Fem Design software. Okay, so that is one way to do it. You just take the model, you make sure it has the analytical model inside Revit, and you transfer the data using StruXML format. The other way would be to export IFC, either from Revit or from any other software that exports IFC, and we can import those IFC files in Fem Design. So it's a wide range of options that you have. You can either use the built-in tools or you can use some other tools to get the IFC from. So it's all up to the user how they want to do it. Okay, so let's continue. We move away from this Revit model. I will keep it open. It's a nice one, but we don't have to see it anymore in my presentation. And we move to Fem Design. So Fem Design, we have, as Chipran said as well, multiple things that you can do inside, but I will open up the 3D structure because it has the most tools available. The other ones have limited options, which are made for only those specific tasks. For example, if you want to do a 2D plate, you can just use this module. You don't have to fire up the whole structure module. And some other things as well. So inside Fem Design, I can open up those two files, basically. One was the StruXML. So let's try that. Let's see how it works. And I have prepared something here. I prepared them specifically not good, so I could talk about what the problems might be and how to solve them. So this is always good to see. So I select the StruXML file that I exported from Revit. And it's taken a little time, not too much. It's like 10 seconds, maybe 20 seconds, something like that, because it's quite a large amount of data that was saved inside StruXML. It doesn't mean that everything could be used. Like here, for example, I could see that only beams and columns were exported, no walls. And the reason for that is that the walls didn't have any analytical model enabled, or they didn't have material. And actually, I can check it inside Revit and see that all the walls basically they don't have materials attached. So whoever made this model, he kind of like missed the material part. Since it doesn't have any structural material, we don't import them inside Fem Design because we cannot use them. We don't know what they are. They are not actually exported to StruXML in the first place. So in StruXML, they don't exist. But of course, if I would fix the Revit model, then I would get the correct one from Revit. But here I can show you some different approaches, which is always good. I will show you how to do the same thing with IFC, and then I can show you how to combine them, because that's something that sometimes people want to do with the models. So I will open up an IFC instead of this StruXML file. Okay, let's see, IFC file. Again, I have, of course, prepared my IFC. Don't want to save this drawing. And I have to decide where the analytical model is located inside IFC. Because in IFC, there is no such thing as analytical model on its own. There are many physical things. It's like 4,000 elements inside this IFC. All the lifting hooks and everything that was included in this model. But no software knows where the analytical model should be. The wall itself has layers, so in which layer should the analytical model be? Should it be in the center of the wall, in the center of the inner core, or where should it be? So we can set some options here if we start the import or opening up the IFC. And we can also set some other options down here if we want to only see structural or load-bearing elements on structural, or if we want to import the original geometry. So for example, if we have elements inside IFC that are not structural, I don't know, stairs, sometimes they are architectural, maybe you want to import furniture, so we can actually import those things using the original geometry. So they will appear as geometric objects inside Fem Design. Of course, they are not calculatable. I cannot analyze a chair or table or something, but I could model on top of them. So I could use the information that is stored inside IFC. I'm not going to press OK because, as I said, it's like 4,000 elements. It takes roughly 5 minutes, I think, to import everything, or maybe a little bit less, maybe 3 minutes. But during this presentation, I don't think that this is so relevant to show how we wait for the import to complete. But what I will do is I will show you pictures of what happens when I would press the OK button. If I press the OK button, then I have to do the mapping inside Fem Design as well. kind of the same way we did inside Revit, but now we are mapping the IFC materials to Fem Design materials. It's the same logic. In IFC, you could have any material. No software will know what this material is, and somebody has to make the assignment. So for example, here we have inside IFC, we have something called concrete precast concrete. What is it? Is it C25? Is it C40? Nobody knows. You have to make the link. You have to make the mapping. Or if somebody who made the IFC could do that, then it's better. So the IFC doesn't contain all the necessary information. It may contain, for example, here we have concrete C40. So I know exactly that I should select C40 from Fem Design database, but it's not always like that. So it's up for the user to select the correct mapping to map the IFC material to Fem Design material. We have different stages. We have the material itself, because IFC has many data points inside. They also map something called category materials inside the IFC, so we have to do the mapping here as well for those materials. It's the IFC. It's built up to accommodate many different data nodes, and we have to just do our best to filter out what is necessary. So we have to make many mappings to get it imported correctly inside Fem Design. And then, of course, the section as well. The same idea, like HC90. What is it? Nobody knows what it is exactly. So we have to make the mapping. We have to know it. The lintel is always very clever kind of way to say something. It's a specific section. So we have to map it to some other element inside Fem Design as well. Sometimes when you do the import, you may get these warning and error messages, which is also, I could say, normal with IFC, because IFC contains a lot of information and not every element can be imported. Not every element that is mapped or described as a wall inside IFC might not be the wall in IFC actually. I've seen like toilet seats that have been marked as glass or something, so they're probably not windows, shouldn't be at least. So these kind of messages might appear. It's kind of normal because IFC contains a lot of information. Some of it cannot be transferred over. But when we transfer everything that we can, and the IFC has been made correct, I would say, or good, then you might end up with something like this. I just imported the walls because I have the columns from the other model already. So in this case, in IFC, we don't have the axis, we just have the elements, and it was imported in the middle of the wall. The wall was layered, so it's kind of in the wrong place. The edges or the corners, they don't go well together. That's how it is when we try to convert from actual physical model to any calculation model. But inside Fem Design, we have pretty good tools to fix it actually. We have something called analytical adjust. It's a very new thing. It's in the latest version. And we can use this one to actually fit or like merge elements together. So I will increase the tolerance a little bit. And for example, we can merge those two together. So very easy way to do it. Also, we could do something like that instead. We could move the wall to grid if we had grid. Of course, in IFC, we don't have grids, but if we had grid or we draw the grids ourselves, then we can move the elements and fix everything together. So it's really easy way to do it. And on top of that, we have something called paste file. So we can actually take one file and paste another file inside it. So let's just enter the coordinates, 0, 0, 0. And the x-axis is, oops, my window is not active. Now it is. Window was not active. I was trying to like grab the other screen, but now it's okay. All right. So we can actually merge two files together. So that's also something that you can do if you have multiple elements from multiple different models, or just like existing building that's already made and you want to put something on top of it. So you have multiple options to do it. Okay. If I would calculate this model right now, I don't actually like the beams. I could extend the beams. We have all the options for it. We have another tool which could extend the beams. For example, let's find a place. Let's find this place here, for example. And I have to probably make it a little bit bigger, the tolerance as well. And I can see that where it is. Sorry, it's down there. It's saying that it's going to like extend it to meet the other beam. Since it's off the grid right now, it's also inclining the beam, which is not correct in my opinion. So I can ignore that one. But I could do that. I could fix it. I could extend the elements to meet the other beams. Of course, I need to fix the other beams first to be on the same level. But I wouldn't calculate it like this. If I would calculate this model, I don't want to calculate every beam separately. I mean, it's just beam after beam after beam. And if I want to add loads, for example, I need to add loads on top of every beam, which is not the best way, I think. But what we can do instead is something like this. We can actually delete the beams, try to delete them. Yep. And we could use a Fem Design feature called profile plate. And we can draw a plate on top of that part here. Let's say the direction of the plate is like that. And let's try to follow everything correctly. It was a little bit off, but I think it's okay for this presentation. No, it isn't. Let's try again. Bad view. Okay, so here we go all the way here, and then we go here, and then we go here, and then we close it. Okay, this kind of structure, but it's so boring right now, but I will make it more interesting to you. I will select the correct sections, select the correct materials. Of course, for the hollow core slab, it's a little bit more than 25. And I can set all the border connections. It's the interesting stuff for engineers. And also spring stiffness between the panels. So each panel could move separately, have their own deflection and such, but it kind of behaves like one big plate. And it's much easier to use this kind of plate to design the building or to calculate it, rather than using those separate beams. Sometimes, of course, we need to use the separate beams, but here we could use this like profile plate instead. And I can even select which part is the cut panel, how big it is, because one of the panels need to be cut. It's not evenly distributed. I can select where the panel actually appears and just apply the loads on top of that as a surface load. Just a second, I will make a random case here, and I can just apply the load on top of that, like that. Oh, sorry, wrong one. Either on top of each element or just dragging with the rectangle. So very easy, very fast, and much better than designing all of those beams separately. Of course, I already have this model. I'm not going to like model everything in front of you. It takes some time. It's very fast, as you can see, but it's still maybe 10 minutes, 15 minutes to model everything, which is not necessary right now. So I have already corrected the model. I've made the plates. I made all the connections, all the right sections for the elements that needs to be here, also the columns and the walls and supports and everything. So everything is in place. Also, what I did is I set the connection stiffnesses for the walls. So the walls are not like infinite stiff things. They have some rigidity, some springiness in between them. They are not stiff like to the maximum. So we could get some real life behavior for the precast elements. Okay, so let's see how it goes. We have some load cases that are already made. We have some load combinations, and I made the analysis as well already. So we already have the results. We have many different results that we can see. Chipran showed some of them to you already. I will just click some of them just to show you some nice ones. For example, the reactions, or what I always like to see is shell internal forces and how the normal force is distributed inside Fem Design, or inside the element, sorry. Just make the scale a little bit bigger. All right, now it's like forming up already, so you can see how the forces are moving inside the building, which is always good to see. Like you can see how the force is compressed between the windows, and how underneath the window we have the green arrow, or not arrow, but green line, which shows the tension force instead. So we get some cracks probably here underneath the window and on top of the window. And yeah, you can follow the lines across the building and see how it goes to the supports. So that's something really nice to see, and good way to actually show it. For example, here we can see how the corners will get big forces, or at least some concentration. Of course, it's quite logical if you think about this, but it's good to see you in the software as well. Okay, so these kind of things, many different results, all sorts of displacements are available. We can see how the plates deform, how big is the biggest deformation, or if I want to have a deformation in a specific place, I can just click on there and see the results. So very easy one. Okay, on top of that, we can of course not only analyze and get the internal forces, but we can do the design as well. Here I can do the design for example, reinforced concrete, and I can select between different options. For example, let's start with the design of a plate structure, either wall or a plate. For example, here, this wall, right now it's not reinforced, but I could go in and check the auto design function, check the parameters of this wall, put everything as it should be, the base nets, base reinforcement, or the additional bars, and set everything, and then just calculate this wall. And Fem Design calculates some reinforcement inside it. It will show us what is the utilization rate on each of the directions, and what's the maximum utilization rate. So pretty good way to see it. And we can not only see it as a table, we can actually see it as a utilization chart. So we can see how this element is utilized, and we can look at the detailed results if you want. Not just some random place on that element. And you can see the element itself, all the parameters that it had, all the thicknesses, materials. You can see what was calculated. You can see how it was calculated. All the formulas are here. If we have something that is according to Eurocode, then we have Eurocode references. Let's just check something. For example, here you can see that this formula, it's based on this formula in Eurocode. So it's very easy to keep track of everything. And in the end, you have many different calculations, of course, everything that an engineer needs. In the end, you have the summary of the utilization as well. It's very, very easy. And this could be printed out, added to the documentation and everything. So it's in a very easy way. Also, we can do something with the beams and the bar elements, not only the walls. So for example, if let's change the visual view, I will select this column. I could do an auto design on that column as well. same idea. We get the results, and we can, of course, check the detailed results if you want. Sorry, not here, but we can check the detailed results if we change to RC bar utilization. It's the same idea. So we get the idea of the element itself, all the calculation sections that were considered. We can see how the reinforcement is laid inside. We can see what calculations were made. If they are based on Eurocode parts, then we see the references. And in the end, of course, where's the end? In the end, we have the utilization chart for that element. So very easy way to see. Also, we can manually design the reinforcement. It's not only auto design. We can go inside Fem Design and check how this element looks like. Where is the reinforcement? We can see the anchoring lengths, if they are good enough or not. We can see the interaction surface in 3D space, so we can see where the load combination points are at. We can draw another reinforcement inside if we want, decide where it should be located, and it's added inside, and everything will be updated. Easy and very effective. Okay, and one more thing that I want to show here is kind of a newish feature for some of you who have seen the software before. Maybe you haven't seen this one. We have a feature called concealed bar. So we can actually calculate parts of walls, for example, as bar elements. It's quite usual to have something like this, that we have like a fictional bar on top of the openings or next to a window or something like that. Maybe like this. So we can design parts of the wall as if they were beams, which is also very cool. And again, we can use the same auto design functions or manual design functions. We can see the utilization rates for those elements. We can see the detailed results for those elements that were calculated, how they were calculated, and everything. So it's very powerful way to do the design. Okay, and if we did everything like this, if we have everything reinforced, then we might up with something like this. It's a kind of final model. We have all the walls reinforced. We have a few beams reinforced, not every beam, but some of them. You can see from the view, every wall has its like reinforcement information on top. We can see it on different layers. So this was the bottom layer, X and Y direction, and top layer, X and Y direction. So it has actually 4 layers of reinforcement. You can even see it as bars, basically. So you don't have to only think about those blue lines, but you can actually see the real direction and how dense they are packed. Okay. So this is the model already reinforced, and I will now pass on this model to Andreas, who will show you how to take the information out from this model and use it in some other place, because right now it's only inside Fem Design. It's not in Revit yet, but let's see how we can actually change that. And again, I encourage you write all the questions inside the question field in the right-hand side, so we can answer them later. Okay, thank you. And Andreas, you're welcome.
Thanks, Tyan. All right, let's see if I can share my presentation. So I will get back to the model that Tyan presented in a short while. But first, I'm going to present the API for Fem Design, what it is and what we can do with it, and then I will get back to actually doing something with it. What I'm planning to do with Tyan's model is to read the reinforcement in Tyan's model, and in some way getting that back to the Revit model that we actually had. Okay, so my name is Andreas Oskarsson, and I work for StruSoft as a developer and a customer success manager, and I'm situated in Gothenburg in Sweden. As a developer, my role is to serve our customers, our Fem Design customers, with easy-to-use API functionality for Fem Design, mainly to help our customers increase their productivity and explore new design opportunities. Let's start from the beginning. What is an API? I think API is a word that's thrown around a lot, but in short, it's just an abbreviation for Application Programming Interface. And you could kind of describe it as a set of rules of how you can communicate with an application through programming. Fem Design has one of these, and it can be accessed in a lot of different ways. So who are using the Fem Design API and why are they using it? So this is a collage from my LinkedIn feed. It's usually full with different spaghetti graphs that magically create some Fem Design model. And they're usually followed by tags like hashtag Fem Design, hashtag API, hashtag parametric design, and so forth. Maybe you've seen similar posts on your LinkedIn feeds, and maybe you're not really sure what these engineers are trying to communicate. So what are these posts about, and what are these engineers trying to achieve? So in my case, most of my feed is filled with Fem Design API posts. So these engineers are basically using the Fem Design API as a tool to create complex geometry, run iterative analysis, automate model creation, automate analysis and design tasks, and much more. They're using this in order to explore new design opportunities and increase productivity and quality. Or maybe some of them are just doing it because they think it's a fun way to work with Fem Design. So how could you leverage Fem Design like all these engineers, and what tools are available? So Fem Design is could be considered as a framework, more or less, and it can be accessed by a lot of different tools. Most common tools are two visual programming languages called, or platforms, or applications maybe, called Grasshopper and Dynamo, where Grasshopper is would be the main pick for people who are working in a Tekla environment, for example. And Dynamo would be the main pick for people who are working in a Revit environment. But then the Fem Design API can also be accessed by more like programming languages like C# and Python and more. So which tool should you use? And I think this is a quite difficult question. A lot of our customers are quite unused to working with programming. They don't have much programming experience. And then I think visual programming languages is a quite good way to get started. And when people get deeper down, they move on to other things. But so if you are mostly curious about the technology, I would recommend you to get started with Grasshopper or Dynamo, maybe even Python if you feel comfortable. If you feel like a more advanced user, maybe the C# framework fits you better. Then you can actually build your own plugins to Tekla and Revit. If you don't like the C# framework, you could start building your own framework using the base for the Fem Design API called StruXML and FDScript data protocol. So I think Tyan might have explained what StruXML was. At least he opened a model called .struxml. So visual programming usually looks a bit like this. Normal programming. This is from the actual Fem Design API, which is written in C#. And this is the actual data protocol, which allows you to write your own framework in whichever language you choose. But this is for the most advanced users, I think, or actual developers. But the possibilities are quite infinite. So there are several tools available if you want to access the Fem Design API, and you should pick the tool you're most comfortable with. Bottom line is that anyone can leverage Fem Design API using almost any choice of programming environment. But if you want to use Grasshopper, Dynamo, C# or Python, I will be available to support you. And then you can send your support questions or any questions for that matter to me or to our support system. And I will try my best to guide you. So I'm going to start showing you a simple parametric model in Grasshopper, and then I will move over to Tyan's model. So Grasshopper is a plugin for a CAD application called Rhino 3D. And Grasshopper is the tool that people mostly use when they try to communicate with Tekla in our business. And the Fem Design API toolbox is available at something called Food for Rhino, where you can just search for it, and you will find it, which is a common kind of like app store for Grasshopper. So let's see if I can share my full screen here without showing my face. All right. So this is the CAD application, and I have prepared a script file in Grasshopper, in this visual programming language that creates. It starts by creating this surface that we're seeing, this parabolic surface, and it creates it based on a rectangle that I've created. So if I move it, for example, it will move that rectangle, and I can so that's the base, that's the geometry. And on top of this geometry, I have all of these options to create elements inside Fem Design. And it's the same type of options that I have in Fem Design. So a lot of people will be familiar with them. So if I want to create a bar in Fem Design or a column, I would use this icon. And if I would want to create a column in Grasshopper, I would use the same icon and feed the information that it needs. So that's basically what I've done here. I created the plates, some point supports. I also created some load cases and a mass conversion table to be able to run frequency analysis. And then I assemble everything to a model. So if I open this model that I've created, it pops up on my second screen for some reason. I don't know why. Then it looks like this. And I could change this rectangle, for example, to get a new type of shape. And that updated shape will be open directly in my Fem Design. As I said, unfortunately, my Fem Design windows opens on my second screen. So I'm not sure if I'm going to try to run an analysis on this instead, but it might get stuck on my second screen. But I'm still going to try. So with the model that I've assembled, I can also run, for example, an analysis. And in this case, I'm going to run a frequency analysis on this. So let's see. So this opens up on my second screen, but I'll see if I can try to move it while it's running. I can't. So I'm just gonna continue talking while this is running. So this is like just an example to illustrate how one can create a model or with a kind of complex geometry and get that working in Fem Design. So I'm actually gonna quit this because it takes too long time. All right, so that was Grasshopper and the plugin in Grasshopper. And let's see if we can switch back to PowerPoint only, like that. And so basically what I was trying to communicate here is that you can leverage Fem Design using programming. And the reason for doing so might be because you want to create complex geometry, run iterative analysis, automate model creation, automate analysis and design tasks, and much more. And you can basically choose the tool of your choice to do this because the Fem Design API is very versatile and works with a lot of different languages. Okay, so now we can actually move on to see what we can do with the model that Tyan just sent me. So I'm going to shut down Rhino, and instead I'm going to open up this Revit model, which was prepared using Impact. And then I'm going to see if I can open up the model from Tyan. And we're just going to have a short, quick look at it. So what I want to do is that I want to move the information about reinforcement that Tyan showed you. So he has already reinforced this model for me. So I want to, so he's the structural design engineer here, and I have really no knowing of what how much reinforcement should be in each wall, etc. But he has provided me with this information. So my job now is to try to just move this to my Revit model. And the way I will do this is that I will try to set up a mapping between my Fem Design wall and our Revit walls. So I will try to map. I need these numbers inside Revit so that I know which wall I should reinforce. So this inner wall, for example, which is part of an assembly named SW20. I want to set a mark on this called BW.14, and the same thing with the next one here. So I can identify these walls later when I'm going to reinforce them. So to help me with this, I have Dynamo, and I have the Fem Design API. So the first step I'm going to do is that I'm going to try to map all of the walls. And when I do this, I'm going to have to make sure that I am on the correct project units. So that is true. And what this script is going to do is that it's going to read all of the walls in the Revit model. It's going to compare the center of gravity of them with the center of gravity of Tyan's model. So the Fem Design API is in its turn going to read this model, read all the surfaces, find the center points, and compare that center point to this model. So if I run this, it will open the model and I get this dialog that popped up on my second screen. So I will just click yes, it will read this model. And it will take a while sometimes, but what happened was that it read the geometry. We can see it inside Dynamo, and we can also see the 2 points here. One of them belongs to Revit, center point of assembly, and one of them belongs to the Fem Design model, center point of that wall, Fem Design wall. So if they are close together, that means it's a match, and that specific wall was mapped. So let's see if we can get it again. And I got BW14. I can check the one above, and it's BW41. And let's see if we can. So that seems to just about right. So I'm quite happy with that. And now I'm gonna open another script if I can get Dynamo exactly. So I'm just gonna quit that one, and then I'm gonna open another script that I prepared called write reinforcement. Now I'm gonna use the ID information that I set on the wall, this mark, to identify every Revit wall with every Fem Design wall from Tyan's model. So again, I'm going to use the Fem Design API to open a model, deconstruct it, get the information from that model, in this case, surface reinforcement. And I'm going to write that surface reinforcement to the Revit elements. And it's going to adjust the area. So if the Fem Design wall was actually looked different than the Revit wall, it would still reinforce the Revit wall based on the Revit wall area and not the Fem Design wall area. And that's why in order to be able to do that, we needed to do the mapping that we did just before this. So if I run this, I'm just going to check the file paths here, so they are correct. I think it should be that one. And then we can just run this. And if this works, we're going to see a progress bar down here because it's going to write a lot of information. So I get this dialog again because I have this model open already. So I'm just going to press yes. It's going to read the model, get the information from the model, and hopefully, maybe it's here, I'm not sure. So Revit is working. So we're going to have a wait for a while. Now we get progress bar because it's generating reinforcement. And let's see if we got this working. So I'm gonna I got the reinforcement into the model. So if I would if I wanted to, I could I kind of wanted to show you how to change some of the reinforcement and get that update, but I did this in a, so I'm gonna actually control Z here to go back a while, but I did the filters too early, I think. Sorry about that. I should have put this on so you could have seen the reinforcements already, but now it's gone since I went back. So I'm actually gonna redo this. Sorry about this. So I closed it. I'm gonna do it again just to show you. So now everything should pop up here directly. Same thing. Read the model, read reinforcement, write to Revit, and that's the thing that usually takes some time. Because we're writing a lot of reinforcements. So regenerating. And I get my reinforcement. So what I want to do now is that I'm just gonna copy this model. I'm gonna open that copy instead, and I'm gonna change some reinforcement, and I want to show you those changes basically. So hopefully this will work correctly. So let's pick this wall, and I'm gonna change the bar spacing to 150 for the horizontals on both sides. And the verticals, I'm gonna change to say 300. Like that, 300 on vertical, 300, 150, 150. Okay, so save, and let's go back to Dynamo, change path to this one, and let's try it again, and we did it on this one. So it will still prompt me with this question since I have this model open already. So it's just checking with me. Hopefully you have a bit better and faster computers than the one I have. I'm using like a business laptop, unfortunately. And we got a bit tighter reinforcement here on the horizontal. Should say 300 somewhere here, I guess. 150. It tries to adapt to this, so it's not going to be exact because it creates sheets to adapt to the windows, etc. But the maximum spacing is 150. So, and the vertical ones are same thing, but our maximum spacing should be 300 to it. All right, so Linus is going to be on after the break, but just to kind of point out, so I have sent this model to Linus, and he's going to show you how to work with this from a technical drafter's point of view, I think. So if I don't want to push the actual reinforcement bars to all of the walls, I might as well just have pushed a text string in some way, telling the technical drafter how to reinforce this, which I've done as well. So I provided a text string for Linus as well. So let's see. That was everything from me. I will stay for a while if there are any questions, but then I will probably leave in 30 minutes or so. Thanks. And now it's time for a break, I think.
Hello, I hope that you all had a nice break and got some coffee. Maybe one of my colleagues can confirm that you can see me and see my screen and hear me. So please confirm that.
Everything is
I will
great,
start.
Linus.
Perfect. So let's start. My name is Linus Karlsson Tyan. I'm the Technical Implementation Manager at Impact at StruSoft. So now it's my turn to take the ball and continue the presentation for today. I will show you the impact design part, and then my colleague Thomas will continue with the project and the production planning. You all have seen this model before. This is the one that Tyan and Andreas based their presentations on. It's, as they also said, created in Impact. And since it's already created, I will actually create a sixth floor here. I know that that Tyan already made all the calculations, so it makes no sense in real life to add a sixth floor, but yeah, just for the presentation purpose, I will show you how to model some elements. So I will show you a little bit of different methods, and yeah, so I'll start with that, and in the end of my presentation I will do the reinforcement part. Yeah, the information that we got from Fem Design through the API basically. So yeah, I will start with drawing some walls, and I will do that on the 7th floor, of course. And just for you to have a good experience, I will also let's turn off a little bit stuff here. This one, for instance. Yeah, so for you to have a good experience, I will show the 3D model here. So you will actually get real-time updates of what's happening. Yes, so let's start. I will start my draw wall command, and since we are using sandwich walls on the other floors, I will do it here as well. Go and find my definition. So in this definition, I have specified what materials to use for the concrete and for the insulation, and also the thickness of the material. I will configure here, so I will start at the floor. Oh yeah, let's see here. Yeah, I think I will need to fix this later on. I will do this one, and I will do this along here. So basically, I will just create a wall all over the place. It's a little bit high up here, so we will need to lower it. But let's see. And this one pops up, and it says that this wall is too big for my lifters, but that's fine because I will split it up later on. So we'll see that. Yeah, I got some more different parts of my wall, but it's placed a little bit strange, so I will try to fix that real quick, or at least adjust it. So now let's see if I do this, then it's moving. Yeah, then we will have to live with having this wall a little bit flying. I did a bad preparation with my floors, I see, so that's why. But I hope that you can bear with me here. So what I will do now is to split this wall into different elements, and I will do that with from my top view, and I will start my that's not what I will do, but I will actually start it here. Yeah, I will do from here instead. So what I will do, I will use the grid lines that I have to split this wall. So I will take this. I will actually first show parts so that you can see what's happening. Go to my split wall vertical, and I will select the reference planes that I want to use for this split, because I want to split this one into 3 elements. While I split, I want to add an end cap between the elements. I will hit OK. And this is what I've done with all the other floors here. So basically, this whole side of the building, I've created a huge wall from here to the top floor, and then just split it vertical and horizontal. Now we don't have the horizontal split in this case, but you can do it in the same way. So now you see that my walls have been updated. We have made them smaller because of the splitting. We have added the edge reinforce or edge geometry, the end caps, and also inserted some lifts. Now I see that they are placed in the installation, but we have some configurations to do before that will place the lifts correctly, and if they are placed in the installation, we will add the panel thickenings around. So that's fine. I will try to add some windows here for this one. So just let me do that. For the windows, I will use the families from Revit as the base, and then I will add some right now with the lifting here. So I will add windows on these 2 elements, I guess. Yes, so I will use the families from Revit for the windows and also doors, and then in Impact I will decide what end caps to have in this window. So let's do that as well. I will go to Edit Opening, select my both windows, finish. And here we'll see what family and type I used, the size of the opening, and here I will just select what end caps used. I just have 1 here, but I'll use it for all sides. So here we see that we got some nice geometry. I will also take this one and add some end caps on the top side and the left side and the bottom, because that won't be added with the vertical split, because the vertical split or also the horizontal will always just add end caps in the split itself. So here I will need to, let's say I want to add this one. And on the top, I could use this one, and on the bottom, let's say this one. And I could do this for several walls at the same time, but just for this, to not wait too long, I will do it for this element here. So now we are just updating the geometry, and I see that I selected the wrong end cap, so it will actually be the corner will be mirrored, but I can fix that with selecting another one. Yes, so this was very basic how to model the elements, but since we already have some elements on the 5th floor here, I could also use them. and just copy them up to my 6th floor. So let's see how to do that. I will go to original so that I can select my elements a little bit easier. I'll select the walls. And yeah, I will select the ones on that side. And I will use this copy move element command. So here I have the possibility to copy elements and place them. Yeah, either I can pick points or I can just make some offsets. Or in this case, I will just copy to a level. So I will copy to level 7. Okay. So what we will do now, because these ones are saved to the database, so they are assemblies. So we will just take the assemblies, make a copy of it, and place it a little bit further up in the model. So we are waiting a few seconds when it's generating. It took more than a few seconds. I don't know if anything happened with my connection, but I hope not. Let's give it some more. Yeah. So apparently I have made some mistake with this 6th floor. Yeah, but we see that the walls are copied, and if we switch to show parts, we'll see the edge and edge geometry as well. We could do the same with the columns and beams and the hollow cores here, but let's just skip that and go with the reinforcement instead. Because I will later on show how to create a shop drawing, but I'll just go to the reinforcement part before that. Because when we generate the shop drawing, the element should be ready for production, and as we all know, we need reinforcement in all our elements. So I will close these plan drawings, and I will go to my impact rebars view. So as you can see here, I got the reinforcement from Andreas, and I just took one wall with reinforcement because this one shows the mesh, and in impact we are using another type of reinforcement for the mesh. So of course I think that Andreas could generate that type of mesh that I need for being able to save it to the database. But yeah, in this case, I just got some rebars, as you can see. So I will use the other information that he gave me, basically the text string here, where I can see the size of my of the vertical and horizontal bars in the mesh, the spacing, and what quality. So I will take a few walls here, not that one, but here. Actually, I will go to show original so it's easier to pick. So let's say I take these 4 walls, and I will take the information that Andreas gave me and use what we call the RC or reinforcement templates. These ones are adding the edge reinforcement, opening reinforcement, and also the mesh for the walls. And in this one, I prepared the mesh from the calculations from Fem Design. So when we insert this template, I will get the proper reinforcement. So let's say these ones, and then I'll get some questions since my elements are already saved. I have 5 copies of this SW03, so it asks me if I want to update all of them, and I can do that. So it might be that some elements in the building are identical with this element here, and they will be updated as well. So now it's thinking a little bit while we generate the reinforcement. And the same here for this SW7. This has one. I think I accidentally put cancel, but let's see. I think it works. Yeah, so now we can see that yeah, it will work a little bit more, but you see some reinforcement added, and in a second I will show you the details on it. Shouldn't take too much time. So what it does now is that, yeah, I selected these 6 walls here, and I actually canceled this one. Yeah, let's continue. So it just replaced the walls with the same assembly name. But if I switch to show parts, you will see that I have generated the reinforcement. So meshes are according to the calculation in Fem Design. And then I've added some mesh. If I take this one away, I've added some rebars around the openings and also around the edges of the wall. So this is pretty nice. I can also do some similar things with the beams and columns. So this time I didn't get the reinforcement for the beams and columns, but that could always be done as well from the Fem Design and the API. But I will just hide some stuff so we can see it a little bit more clear. So I've added some rebars and I see that I've deleted it, but I can just take my element here. I will take these beams here and use something called rebar template. So since I didn't get the rebars added to the element, I can add them with impact software as well. So I will use the inverted T and OK. So now we will generate the reinforcement, the stirrups and the straight bars for these ones, and they are saved to a template. So basically a user will need to reinforce one of the beams manually and then save it to the impact database, and we will use that information to generate the reinforcement in all the other beams. So since Revit is parametric, so we don't need to care about the length or the size of the beam. We just need to have the information about what rebars to add and what sizes and so on, and we will adjust that to other sizes. So I could probably just quickly delete these rebars here, and yeah, I'll just add a new mark for a while. So this one you see is much shorter than this one here. And if I add the same template, so let's invert T, sorry. I will get I won't get all the same amount of reinforcement, but I will get the reinforcement that are suitable for this this length of the element. But yeah, I see that the time is ticking, so I would like to show you more, but unfortunately my time is soon running out. But I will stop with creating a shop drawing, and I will do it for this one here. Actually, I just go to my impact dialog and use my create shop drawing tool, select the template that I want. So in this case, the sandwich wall shop drawing template. I won't do this process because I already have a shop drawing here, so I will just show it. But you could select one or more elements at the same time and do this shop drawing generation. So they will be placed here in the assembly list, because as we know, the elements in impact, when they are saved, we are saving them as assemblies. So here we can see my main drawing. It's very basic, but we get the lifters here and the geometry, the windows dimensioned, as well as here we get some details for the end caps that were used, and we get a section list with the openings. So here we see the windows and the amount of them, and the geometry measurements. And here we see the list of cost materials. In this case, we just have one, but it will also be placed in this list. We get the reinforcement generator. So here I have a drawing with just the reinforcement added. So for the loose rebars, I get the tags here, but instead of having the mesh just messing everything up with a lot of lines, we are representing this with these diagonal lines, and here we can see the naming or the definition of the meshes, which is pretty nice. And here I can also generate a list of the rebars used in the element, but in this case I just have straight bars, and my list is configured to only show stirrups, so that's why I don't have it here. But let's say that I would add the stirrup. Let's say I would add create a shop drawing for the beams I made. I will get a list with all the stirrups in this this element. So yeah, I will actually try to save these walls up here. So basically just mark them and go to save walls, and this will be the last thing I do before I hand over to Thomas. So Thomas will, when he updates his model, he will see that these elements are added, so he can do some fun stuff with them. He can probably, he has something planned, I guess, but let's see. So yeah, that was impact design in 20 minutes. It's we are just showing very basic stuff, but if you're more interested in the details, we have some videos on our YouTube channel, and you can always call us and arrange a demonstration. We can go through yeah, the process and the tools more in detail. So I will save them, and yeah, I will thank you for your attention, and I will give the screen to Thomas. We cannot hear you, Thomas.
Thank you, Linus. Thank you a lot for a great presentation in Impact for Revit. I hope you can all see my screen and you can see me also. I would like to welcome you also from my side to today's great day. I will be the last person from StruSoft to do a presentation, and I will kind of try to close, bring the whole thing home as this an American expression that they have. I'm Thomas. I'm working as also the technical implementation manager with Linus in the impact team, in the precast team. And today's webinar has been a dream of myself, because this is basically what here at StruSoft we say is what we do is we go from design, even though structural design, drafting, all the way to the construction side with your precast elements. And I'm very, very happy to be a part of this day. Before I go into the live presentation, I made a little small introduction about impact, because of course we discussed a lot about the structural design, and the guys from the structural team made a great presentation. And Linus showed a little bit about impact design. Of course, as he said, he only scratched the surface of what we can do and what the possibilities are there. It is very difficult in the 20 minutes to design, walls and columns and beams, and that's what we try to show, that in a very small amount of time you can actually produce shop drawings through our software. So I will show you a little bit how I always like to start a presentation. What is impact? What are the possibilities through impact? I will focus on the impact production and project management, and then I will talk for a couple of seconds about the production process, and then I will show you live takeover from Linus, the model, and plan it for production. So what is impact? Impact is an SQL database. As you could see, there are a lot of possibilities, integration from design data, coming from AutoCAD, coming from BricsCAD. The one that you just saw was from Revit. So basically what we do, we populate the database with design data, either from Tekla, Excel, XML, JSON files, and soon to become from IFC, as of course Tyan and Andrea showed you about Fem Design. So we populate information in the database, and what we want to actually take is use all this information to plan our projects efficiently for production and erection. So what do we have in the impact production modules? Of course, what I'm going to show you and I will focus on is the project manager tool. This is where we plan our projects for the word says it itself, is project management, and at the same time we can use the cost planner and the transfer planner. The resource manager is the tool where we actually plan multiple projects. This is the tool for the production planners. This is the tool for the people sitting in the factory planning the models onto beds and tables for production. And you can combine multiple projects and of course get top level detail for your factories. If you have multiple factories, multiple divisions, you take top level information for the whole company from that tool. Impact Go, the mobile app, a great application that is basically the glue between, at least that's how I want to call it, is the glue between the offices and the floor, people working on the factory and people working in the offices. This is where the amount of information coming from the factory populates the database, and the information and the elements get the correct amount of information, so everybody gets notified of the status of the project. Of course, we have developed a new element control system. We have a quick cost estimation tool where you can gather your cost. Another tool called, of course, custom reports coming directly out of the project manager, and another tool called tender quantities, where you can populate your database with projects in the future that they are not even come yet into your company. As Andreas talked about API and the Fem Design API, we have developed the same application, or kind of the same application. I'm not a developer as he is, so I'm not very much into detail, but maybe our customers at the end will explain a little bit how maybe they have done some integrations with their own homemade finance systems through the Impact API. Of course, this is what we're going to focus on today, and because I have to keep it short, I will focus basically between the project manager and the resource manager. What I discuss about the process, for you, of course, you understand. If you are working in a precast factory, you understand that basically what we want to do is take the elements, you know, from, as I said, design to the site, the most efficient and productive way. But we separate the planning in impact into two phases. We have the planning phase, which is what we call the rough planning or the ghost planning, depending on the country using the expression, and we work backwards from erection, transport, cast, and drawing. That means that the project manager can go set an erection date, a day that he wants to have the elements on site, and from that on, the software creates automatically transport, cast, and drawing dates according to dependencies. However, when we perform, when we fine plan, we have to have the element ready for production, as Linus is doing right now on the background. We have to, when the element is ready for production, we have to put it on a bed to actually see it in 3D, put it on a lorry, put it for transport, and then on the way to the site. So, and that's what we're going to do. So today I will try and show you live. I will open the project manager, as you can see. As long as Linus, now this is the initial model, the one that Linus showed in the beginning. As long as he saved his walls, I can just reload the model. And because we work in the same cloud database, and when of course we say cloud, of course we speak, you know, it is on the cloud, it is accessible by anybody with an internet connection and the correct amount of details. You see the flying walls that he just saved in Revit. Of course, it might not look nice, but this is a webinar also to understand the possibilities and the capabilities of the software and the integration between different departments like the production and the design. So what I'm going to do in this situation, I will play very quickly some roles. So at this stage now of the presentation, I'm going to be a project manager with a rough model detailed right here coming into the project manager, and I will try to set those elements for erection planning and then give them some dates. When I continue, I will become a production planner. I will find those dates that I set as a project manager. I will set those elements for production, and when I finish this process, I will also do an element control and put some of the elements for transport planning with our new 3D transport module. So as you can see, I have the model separated into floors on the left side of my screen. Of course, the views are modifiable, and I can double click here, floor 1. I can see the floor 2 with the slabs from the previous floor, and moving on and on, I can filter out things. So if I go back to my whole building, the one thing that I don't have is the erection sequence. I have set erection sequence for the initial model, and now I'm going to set erection for the elements that Linus just created. So I will select one by one. I have the possibility to either select them on the way that I want them to be erected, or use the element mark as a reference. Every element, of course, as you know, has an element mark. I will add the elements here, and by adding the elements, as you can see here, erection sequence number here is 0. Erection sequence number here is 211. So I'm giving them a new erection sequence number. I will add the elements, say apply, and now those elements have an erection sequence. So now, when I have the erection sequence number, I will go to my simulation. This is a fancy, this is kind of a fancy, how do you call it, application, but it is very useful for project managers. You can share those details with the people that you are working, external partners, and you can actually discuss how the model you would like to be built. And of course, it is very easy to change along the way. And this can only be done with just an initial model, right? We don't have to have a finished model completely. We can either import elements from Excel and do something like that. You can see the model is being built up, and the last part, of course, is I'm not going to do it again now because I don't have time, but the last part is also made. So I go back to the model. You can see again how it looks. And now I have set the erection sequence, but the question here is, why have I set the erection sequence? And the answer to that is that me as a project manager now, I have a rough estimation of what I want to do with the elements. So as you might notice, an element can have the same element mark along the process, like those two, but our software generates a unique ID number. In this case, for those two elements, is like ID 8 and 9. So when I do the rough planning, I will always do the rough planning through the element IDs. And as I said, rough planning, setting date. So I will take a great filtering options, of course. I will take my erection sequence number, and according to my erection sequence, I will try and plan and give them a planned erection date. So you can see here now my element types are only sandwich. I can clear the filter and get, of course, all the corresponding elements. So in this case, I will keep only the sandwich walls, so I can just work for my walls as fast as possible. So what I'm going to do is give them a planned erection date, select here, give them a date, drawing, planning, and then set a date. The date that I would like to set would be the 14th, the 15th of April, a good amount of time for them to be done. So when I set a date here for those elements, I save changes, you will see that the plant drawing, plant production, storage, and delivery date will be fulfilled automatically. So I want the delivery date to be the same as the erection date. I want the storage date to be the 9th, and the production date, I want it to be the 8th, and the plant drawing date, I want to be the 1st. In the same logic, I can take the walls from the 2nd floor, for example, and just set another date also. You know, I want the 16th to be, or the 17th to be the day for those. I will do that also. I will say apply, save the changes. And you see that the software automatically, according to the dependencies that we have set, goes backwards in the process. So I have done that now. I can go back to my model, show the whole thing again. And then, as you see here, we have different colors for different functionalities. So if I go here to erection, you will be able to see that all of my elements as a check have an erection sequence. But what it is important to know here is the status. And the status here tells me, as a project manager, it tells me a story. It tells me at all times where my elements are and what is the status of me following. So the moment that I set the erection date, the moment that I set the planning, then I can only just follow the status. And the status for me right now tells me that the first two floors are ready for production. The rest of the building is not ready for production. This is something that just Linus did on the background, and that is why this tool is very powerful and fantastic, because at the same time that I'm working on something else, another person is setting those elements ready for production and producing shop drawings for them. So ready for production for me, stop being a project manager now and become the production planner. So the production planner, of course, has multiple projects that need to plan and has a factory that he needs to run. So what we do is basically go back to the resource manager. We set the correct planned production dates. Today is the day that I want to plan, for example, my next week or the week after that, or even this week, if that makes any sense. So I set the planned production date in the software, all of the projects, and then I will say what it is unplanned, and of course what it is ready for production. Then I will just press refresh data, and by doing that I will just get all the elements that I just set right now, that they are from here. So I can see here that the planned production date for those elements, I can take it even up. Say I have those elements, those 10 elements that they need to be produced on the 8th, and I have the other 10 that they need to be produced on the 9th. So I will select my elements from here, and I can even drag and drop them or I can just multicast them to specific to my beds. So I'll take my factory is pretty empty here. I will just multicast them. Multicast, start. This is a warning about the mass. We have set some mass specifications for our elements because according to the crane that we have on the floor. In the same manner, I'll take those elements also for the 9th and also multiply them on those beds. Start, yes and yes. There is some very big elements there. So I have added them on the cast planning module. This is your cast planning module. I can double click on the bed. And if I double click on the bed, you will be able to see the elements laying on beds in a full 3D mode, lying inner panel up, inner panel down, depending on the settings that you have. You can see different, of course, information about them. And if you want to take things, you can just take them and move them around. You can always drag and drop, use them. You can rotate them. You can just populate your day however makes sense for your company. So I did that in the resource manager, but if I go back to the project manager now, me without doing anything, you will see the cast planning here is empty. It's kind of the same week. If I press refresh data, the data here is populated here. And this is the advantages that we get by running this through different spreadsheets, through different Excel files. And when I update my model, I'm expecting to see some of the walls getting a different color at least. Of course, this is something that happens live. If, of course, you are not opening the same project, right? So the color changes, but because now I'm working on the same basically file, I need to update to get those modifications. Now, as a project manager back again, I know that those elements are planned for production. And an extra topic here, usually what I do now, having a cast planning, having populated my cast planning day, I can just select my elements. I can print out specific cast reports, element labels, of course, cast calendar, put it out there in the floor so people know what element is going to be produced. And when I do that, I generate QR codes, unique QR codes for each element, and by doing that, I can use the mobile application that I explained to you before. Because now I can see I don't have time to do that live. I have done that many times live in other videos, and at the end of the webinar we can guide you and show you where you can look and find for those videos in our YouTube channel. So if I now go, instead of doing the element control inside the mobile app, I will just do the element control here. So I will just open the element controls. As you can see, I have added a basic pre-production control and a post-production control. And my pre-production control consists of checking the custom material, the form or the bed, and if I have the drawing, we save the changes and save the changes. Now, everybody knows now in the database that I personally have performed this control at the 24th of March at this time, and also I can add images taken directly from my phone. By doing that now, closing this, you will see immediately, I didn't even have to press update at this case, the element changed status, changed the control status, and the control, which means planned and approved. So that means that it is ready for production. And when it is ready for production, and let's assume that we have done controls for everything, we set the status for the bed to produced, and that will also automatically change the color of those elements. We change the color of the elements. Following the process again, I know those elements are produced. And when they are produced, that means that I can perform the post-production controls, set them on a storage, and again, a post-production control in this case has the possibility of adding, checking some simple checks like this one, like color, sandblasting, and different types of facade. But also you can have measurement checks, like you get the design value in your mobile application, and then you can set the actual value and do that. Now I'm not going to do that to waste time. Again, this is something that has been showcased many times. Save changes, and immediately, of course, expecting now again when I close this element to turn into this nice dark purple color, naming that it is produced and approved. So finish with my cast planning. I have my first two floors, first two sandwich walls ready for production. So I will go and showcase for the last 4 or 5 minutes of our transport planning module. This is with the right setup and with the right amount of information about your vehicles and about your stack templates, we can create something extremely fast. And that is, I will just take the sandwich walls of the first floor, I will select them and plan them directly for transport. I will select first one. I will select my A-frame, and as you can see here, two very important things is using the element dates. So the dates that the project manager has set up in the beginning, if we actually want them to be fulfilled, so instead of us selecting load date and time, delivery date and time, which of course we can do, we have the dates automatically taken from the beginning of the project. So we use the element dates and erection sequence reversed. Erection sequence reversed, meaning especially, for hollow cores, for walls, it doesn't really matter, but for hollow cores means that on the pile of the hollow cores, the last one on top is going to be also the first one erected according to the erection sequence again that we have set in the software. So when I do that, I will create my vehicles. Immediately the status also changed to you will be able to see when I refresh the data, of course. So the status has immediately changed to, can go and see, planned for delivery, and you can see my vehicles and how a 3D view of my A-frames and my walls. And at the same time, we create transport vehicles and stacks. In the stack planning, the stacks are also created. So here in the stack planning, and this is going to be more easy to show you on the second floor, because now I'll go to make transport planning for the second floor, select my walls, and now I will put them in an inloader as another type of vehicle. So you can see a little bit of all the different possibilities. You can see how fast it is, you can see how easy it is, and here you get also a usage rate. So you see how much of your elements is fulfilled. And here, of course, I cannot move the elements around the stack. It is separated into different things. But here in the stack planning, I can actually, go to the different types and take a wall from here, for example, and move it here. When I do that, if you notice, maybe it's too small to notice, but if you notice down here, we have the center of gravity updated automatically of the whole thing. And of course, when I go back to my transfer planning, you will be able to see, if I refresh the data, that the wall also moves in here. And the last thing that I want to do, just as a reference, before I give the floor to our customers, which is more important to hear from them than hearing from me, I usually do the implementations. So I do this a lot of times, and I have showcased that many times, but I think it's better to hear from the actual customers and the experience that they are getting from a software like that. I will just make a transport for my hollow cores on my track. Just put them here. Yeah. Of course, if the dates are off and stuff like that, then the software is going to give you some warnings, of course. And are you sure you want to continue like that when the dates are not? So I have created new templates here, new stacks. And in this case, I can see here that I have 32% and 82% here. Of course, I will exceed now what I have set as my track capacity. But you know what? Because now we're in theory, it doesn't matter. So I will take my stack here, cut it from this, and I will go in this 82 and paste it in this one. So in this case, I will just paste it here. And when I do that, I will get a double stack. And I can either put them next to each other or behind each other. And of course, while I'm doing something like that, you can see also there is the center of gravity of the vehicle. By doing that now, I have filled up my vehicle maybe a little bit more, but I have saved one full transport. Of course, delete that and delete the stack. And that is my presentation for today. Very quickly, I showed you some of the key features of Impact, and I will now give the floor to Mr. Tarmo Idarant from PCC project. And yes, and I would like to thank you all for being here for the presentation.
Thank you, Thomas. Can you see me and my screen?
Everything is great, Tarmo. We can see your screen, we can see you. You are ready to go. Thank you.
First of all, thank you for StruSoft to giving me opportunity to speak in your event. My name is Tarmo Idarant. I'm a CEO of PCC project. And first, I will couple of words about our company. Some of you know us, some of you maybe not. PCC is a structural engineering company established in 2002. The company was established by 4 structural engineers. We are located in Tallinn. And currently we have about 30 engineers in our staff. And we have been collaborating with StruSoft since 2005. Our main business is structural engineering. And since the founders of the company came from the prefabricated concrete business, then a big part of our business has been also prefabricated concrete. That is designing prefabricated concrete structures and then doing also shop drawings of elements. And we are also doing quite a lot of steel structures. And more and more, a bigger and bigger part of our business is sort of this consulting type of business where we do preliminary design, give some expert opinions, assess structures, and also do some product development. For example, if a precast company wants to come to the market with some new products, and they need like engineering support, then we could offer also this kind of support. Big part of our business has been in the Scandinavia over the past 10 years. Since the Stockholm housing market crisis followed by this COVID, we have shifted our attention more to the Estonian market, and today it's about 50-50. And in Estonia, we are doing at the moment one hotel building in Pärnu in Tallinn. Then we are doing a couple of apartment buildings in this Volta quarters in north of Tallinn that has been on the news. And also we are doing this design of the Rae State Secondary School and sports facilities. And some of you who would like to join our team, then I would like to point out that we are a family-friendly employer, and we won the best internship company title last year in the category of small businesses. And we are also proud members of Estonian Association of Consulting Engineers and International Federation of Concrete, FIB. And now I will walk you through the projects that we have designed over the years with the help of StruSoft software. And in the end, I will show a little bit more closely some of the recent projects that we have done. First one is a residential building in Stockholm. Our customer was Abetong, and it was about 15,000 square meters, and was finished 2015. Then we have a library building in Göteborg. This actually was a renovation project. There was a small extension to it and the new facades around it. And here were quite complicated sort of balcony-like elements that later on the site there were brick columns laid on top of them. And here our customer was UPB from Latvia. Another project in Stockholm, Quality Hotel Globe. It is next to the Globen and the Tele2 Arena, and nice hotel building. Our customer was also Latvian company Skonto Prefab in this case. Here is a big apartment complex, I would say, in the middle of Stockholm, Liljeholmen, about 25,000 square meters, and we designed all the prefabricated structures here. Plus, we did the overall stability analysis with the help of Fem Design 3D structure, and yeah, there were all kinds of concrete elements, starting with the sandwich walls and ending with the filigrane slabs and double walls. Hospital building for New Karolinska. And here is a hotel and conference center in Helsingborg. This was a really complicated project. No straight columns, no straight angles, no straight nothing. And this was the project where we successfully used the Revit to Fem Design link, because the engineer who did the stability and overall analysis, he knew very well Revit and thought that he can do the model much quicker in Revit, and he did, and then he successfully imported into the Fem Design and calculated it. Here the concrete parts were designed with StruSoft Impact, the hotel part and also the concrete part in this conference facility. And here I have to say that the steel was designed by the competitive software competitor. And here you can see this picture when this was in process of construction. Here is some office building also in Stockholm near Globen. Here you can see that we have done some analysis in the Fem Design for the walls, and this was elements were designed with Impact. And here is the picture of the finished building. Some parking structure. Also, you can see here a Fem Design model. Everything is in, and here is the finished structure. Quite big apartment complex again in Stockholm, analyzed in Fem Design 3D structure. Also, you can see some architect model and the finished building afterwards. Some smaller student apartments. Also some smaller apartment building, and once again one parking structure in Malmö, Sweden. And now I will come to the more recent project. This has been the biggest project last year that we have had. It is called Tallinn School of Music and Ballet. It is located in the middle of Tallinn, and I'm going to tell a little bit more about this project. First of all, this project actually has been going on for a long time. In 2011, Austrian architect Thomas Bucher won the architectural competition, and it has been in the design ever since. All those nice renderings that you see here are gratitude of the architects. And we started this project in December 2019, when the tender for the main contractors came out. We started right away helping Merko Ehitus Eesti to put together the tender. And when the Merko got awarded the contract in February 2020, then we right away started the design of this building. As I said, architect is Thomas Bucher from Austria. Our customer is Merko Ehitus Eesti. There is 5 floors of this building. One is completely underground, 4 are above the ground, and the area is about 24,000 square meters, which is quite a big building for Tallinn. Construction is in process at the moment. This design is almost finished. I saw that there are listeners from other countries. I don't know how it is in these countries, but in Estonia, the structural engineers who participate in projects, they are not very often recognized, and maybe not at all even. So I would like to use this opportunity that I have some audience, and I would like to thank the team who has worked their butts off for over a year to put this project together. And here we go. Our engineering team was Tanel Kullamägi, Kalle Kiristaja, and Veiko Vill. Our modeling or BIM team was Ants Ratchkov and Tavo Tinno. Our management team was Artur Tšapenko and Kaspar Laurimaa, and the team was actually much bigger. I am not going to read them all. These were the sort of key persons. And also we had in this project, we had a couple of sub-consultants, Sirkel and Mal, and the Inseneribüroo Kandev, who helped us. And also there was involved a sort of site consultant from the customer side, Siven, who did a small but significant part of the building. So to all of you, thank you very much. And you have done awesome work to put this design together. About the work we did, as I said, we participated right from the beginning when the tender for main contractors came out. We helped Merko to put together the tender. And then we did all structural engineering. We built Fem model in StruSoft 3D structure, calculated the whole structure. We optimized the foundations. Initially, there were like pile foundations designed, but actually we used StruSoft Fem, this relatively new soil model, and we were able to optimize the foundations. So we replaced the piles with a slab foundation, and also we removed some unnecessary dilatation joints, and also it was like designed like a double floor in the underground floor, so that if there are some leaks, they can gather the water between the floors, and everything will be dry. But we decided to remove the top floor, and we used some special additives for concrete to get the watertight concrete. So this was built actually with one slab instead of two, and all much more simple. We did also complete sort of BIM model or documentation in this level of development 350. And what I mean by that is there is a small picture in the bottom explaining it, that we had all casting materials in. We didn't have reinforcement for the prefabricated elements in, but we had the reinforcement in for the cast in situ part. And yeah, together with this team and sub-consultants, we designed this complete building together with shop drawings. Challenges for this project. The biggest challenge was time schedule. Time schedule was very tight. When the main contractor got awarded the contract, they were eager to start digging and pouring concrete, and basically at that time we started to redesign the foundations and doing all the general calculations. So it was a real challenge. The next big challenge is that there are a lot of specific acoustic requirements for the building, because this is a school of music. There must be all the classrooms and must be very well insulated from one another. So this made all the partition walls very heavy, and it was difficult for the slabs to be able to carry these loads. And also there were a couple of very unique solutions, like a deep beam or wall made of concrete with a span of 30 meters that carried free floor slabs, and additional steel truss with a bit smaller span for the same reason that there is some hole under it and there can't be any columns or walls. This deep beam was calculated with a strut and tie model. Unfortunately, we couldn't use StruSoft software for this, but everything else is done with the StruSoft software. And here we can see also a picture of this 14 meters long steel truss in the building. For this BIM, we went for this impact hybrid solution. This means that we used impact Revit for modeling all the precast concrete, putting in all the casting materials and anchor bolts and etc. And we used the impact AutoCAD for shop drawings of precast concrete. Additionally, we used this plain Revit for cast in situ and general assembly drawings, and advanced steel we used for steel shop drawings. And why we decided to go with this impact hybrid is that first of all, it's a cooperation with other parties, because nowadays everything is BIM, and Revit is this sort of this language that all the other participants can speak. And also, since this is a state project, there are state requirements for this BIM, and we tried to follow them exactly as needed, and Revit gave us this this possibility. We could not have done it with impact for AutoCAD, for example. We could make the model there, but the information that is needed is impossible to get there. And also one reason was that we have multiple materials in this building. As I said, cast in situ, we have prefab, we have steel, we have everything, and the Revit can handle all these materials, so we could have one single model. And it's not all, it's also important that the Revit is a modern software, so yeah, we are trying to move towards this Revit as much as possible. And Impact AutoCAD for shop drawings, it was very efficient way to produce the shop drawings, and we have plenty of skilled designers in-house available to do this job, and it would have been much more difficult, if not impossible, to do it in Revit all the way. Here are some examples of the wall element or wall element. That is, there are a lot of this kind of quite wall elements with kind of strange shape, and in the end there were practically no identical elements in the building. I think in the end there was one position that had two pieces. Otherwise, everything else was different. And this is the picture from the site this morning. This is how it looks like at the moment. They are doing starting the roof works on the left side, and they are still assembling a little bit on the right side, but it is getting the shape that it will be on the site as well. Then I have also another project I would quickly like to talk about. It is KV Lugnet Bromölla. It is in Sweden. We have a Swedish customer called Starka Betongelement, and it's an elderly home. And we decided with this customer that we will do a test project and try to do it all the way in Impact Revit. We started up, everything looked good, but in the end we fall back to this hybrid solution because there were some things still in this Revit for Impact that we couldn't do for the customer. This is a very special customer, and he has some things on the drawings have to be exactly like they want, and we couldn't do that with ease. We could have done that, but we felt that it will take too much time and effort, so we fell back to this hybrid solution where we do everything in the model in Revit, and afterwards produce the shop drawings with Impact AutoCAD. And looks like this model works very well at the moment. And to wrap this up, this is what this for us what this impact design means in 2021. It's mostly about the data. It has always been driven about the data and the customer's need for the data. And nowadays everything is in the cloud. We have set up our own cloud where we can use our standards, and we have several customers where the cloud is in customer's place, and we are using their servers when we do the work. And what this actually means that collaboration gets much closer. The customer has always the latest data, and we have the latest data. For example, if we put one element ready for production, customer sees it immediately. If they plan their deliveries, we can see this planning data. We know if we can still make some changes or not, or is it in the pipeline to be produced. And we don't have to do. We can skip a lot of this boring work, making reports and exports and sending drawings, and they can access the data and drawings and whenever they need. And this cloud has actually enabled this remote work that we have going on for a year now. because of this COVID-19 situation, everybody can work in the home if they like, and they can sync the files, and everything is running very well and quickly. And in this picture, you can this is a picture from one home office at the moment. This is it. Thank you for listening, and I also would like to thank Taavo, Tanel, Ants, and Daniel, who helped me with this presentation. Thank you.
Fantastic presentation, Tarmo. Fantastic. Great stuff. So now I'm going to give the floor to Mihail from TMP Element, also located in Estonia. And here we are. Good luck, Mihail. You can unmute yourself and we can see your screen. And if you have a camera on, you can also open your camera.
Hello, do you see me?
Not yet, but pretty soon. It's just the camera button next to the presentation, underneath your microphone.
Mm-hmm.
Yes, perfect.
Hello.
Great.
Okay. Do you see my screen?
Yes, everything is great now, so you can start with your presentation.
Okay. I'm Mikhail. I'm from TMB. I'm the engineer designer. So we have a precast concrete company located in Tartu. So I work here for the last 10 years. So the small presentation of our the last 2 years we have been goes to the impact. So we work on it. So what we do in our company, I make sales for the hollow core slabs and management as well. So how can I do it? I just show you what we do. Do you see my screen?
Yes.
When the clients come for us, we make them an offer calculation. I use it for the also they comes from 2D. So I make them to the impact. It's just what we do. Make them copy. So I go to impact. I make the new project. Make them pre-phase. Make the floor. So I have the floor one. I open it. So this is the sketch from the 2D. Impact goes the drawing elements. This is our hollow core. So I make the quadrant of them. It's very easy to calculate and to draw the elements. I just make the quadrant.
Yeah. Ну, хорошо, тогда ты знамение.
So
Вот здесь на чертеже и писал чертеж, что я поставил.
this is what I exactly do in our
Больше мне пока не попадает.
company. So this is the sales stadium. I make an offer for the client. It's very difficult holo course. As you can see, it's they're small and too much but it's finished. So it's my holocore. And the holocore 22. I put them. Oh, 34. Go. Yes, ready. Ready. Yeah. I make this is the cotton. Ready. Next. Yes. Okay. Here you see it's another one. Do you see me now? It's the right length. As you can see, a lot of design projects do not have the 3D, so they send to us 2D. But it's very easy to make them 3D to impact. Next. Yes. Yes. Okay. When you have some bigger project, you don't have to make all the scatters, so you have to draw the big holocaust slab plan. So it's very easy to make the plans. The next one. That's how we do it. Next one. So that's it. So now we have openings. This is a very big opening, so we can do it, but again, make them cut. Yeah, you can see what hollow cores and the ribs are here. This is opening as well. I make another opening, but for the client and the prefers, I have enough information for the offer calculation. So I make them all named. I give them automatic name. We have tab 22 and 101, and it makes me automatic naming for the whole plan. That's it. So now I have the plan. So I go to impact. Okay, here we are. So we have all the elements here. There. So I select them all and have the information about the area. It's 2091. 2090. I make the calculation to the clients from this area and make them price if the client accepted. So I have elements drawing and in the impact. So I go back to the AutoCAD and make the shop drawing for them. Shop drawings, it's very easily. I mean, one click, everything element marks, and okay, first of all, I will make them. It's 6 stranges. We have a precast, pre-stressed stranges. So I make the quality. I have the calculated them. It's doing with some static programs or some tables, or you can make it in impact. But we make it with all the program and our tables, our drawing tables. It's okay. It's good. So I go make the shop drawings. It's the same, very easy. It goes for just a second. Makes all the shop drawings for the object. So it's finished. I go back to the impact. So I have the shop drawings here. It's good. The next stage is planning them to the test planning. So I make the, for example, 29. It's the empty line. I put them all here. It automatically goes. It shows me that the line is full. It automatically makes the cotton elements here and here. Here, see what how line is prepared. After it, I go to the stack planning. Erection planning is the number of erections. So in object, I make them, for example, this line, erection will start from here to here. Add elements, 1, 2, 3, 4, 5, 6, 7, apply. After it, I go to the stack planning. I make the one stack for the car. When the hollow cores are ready, so I make them to stack. Here I can see what status of them. Are they ready for production? Are they planning to the transport? Are they casted or no? What stacks they have? The elements, stacks. And then after it, we plan it to the cars. Our logistic group make the car for their stacks and goes to the client. So probably I do all work for the sales, for the project manager, and for the designer. So it's very easy to complete the project. So I make the calculation to the client. The client accepted. I make the drawings. I make the project management for this project. I make the erection plan. I put them to the car, and all work is done. So it's very easy us to cooperate with client. Probably this is what I do. This is the summary. Here I can see what's the cast planning. Here I can put the production dates when they must be to our logistic store. So I put the date here. For example, it must be on the 26th. The cost was 28, so all see that there must be 26 here. Say erection date, I said the same as the cost, or not the cost, the 30 or 31. So everybody see it. The logistics see, our product manager see, who makes the cost. And that's it. That's the project that's finished. I go to another project. So that how it works.
Fantastic. To mention here, you're working with Impact 15, the previous version of Impact. That's why it didn't look quite the same as mine, right? Because we still have the integration with your financial system, with your economic system, right? So we have done, as I said before, some API connections through a custom-made finance system that they are running at TMB. So that's why we need to upgrade. We're waiting a little bit before we're upgrading to the newest version of Impact. But that was great. We can see in real life, like how fast, in less than half an hour, how fast you can actually, do your job, and how that changed your life. So I think that's what the real life experience is. So thank you for that, Michael. That was great. I will take back.
And as well, the next stage, the next floor is the same. So the next floor, I just copy.
You can just show that also to everybody.
Copy elements. I just make increase the element number to the floor. Okay, I need to make the second floor.
Exactly.
Here, floors, second floor. Okay. So if the floor is same, I just put them copy and increase the number. Let's make the new element 101, 201. It's a couple of seconds. It's done.
Fantastic.
So
and now that
we have this. Yes.
Just rotate it so it is a little bit. Yes. Fantastic.
It's the second floor. The second floor goes the same way. I just put them fully automatically to make the shop drawings. The same, put them all the information here for the logistic, for the client, and for the production guys.
And you can generate the elements also in AutoCAD very fast also, right?
Yes.
In an AutoCAD drawing. Great. I think that's it. I think I don't want people want to go for lunch, so I don't want to keep anybody more than they should. Thank you so much, Michael. That was a great presentation. Make a presenter. I will make myself a presenter again, so you can see my screen. I think. Can you see my screen?
Yes.
Yes. Great. You can see me also, I hope. I have made a little slide here to thank you so much for today's event, for attending this event. As I said, this was a dream for me, that we can combine both our structural and our precast teams together and show you the power of our software and the power of the workflow. I know some of the things were very technical and a little bit advanced for some of you, but at the end, I'm really sure you understood the point, and the point is from structural calculations, create the reinforcement in our models, and then plan the elements for production. If you want to find more information, of course, you have our StruSoft webpage. Of course, most of you know our webpage. You can follow us on social media, on LinkedIn. We always post great stuff there, and the new developments and the new features of the software. We have our StruSoft official webpage on YouTube, where we also have a lot of explanatory videos. The webinar is also going to be posted there, so you can also revisit and see the highlights of today and maybe go back to it. And of course, some wiki information both for Impact and Fem Design, and a new blog specifically for precast we made for Impact. And you can find the webpage here. Yeah, that's it from us. I can see that there are not so many questions on the questions field. So I think as long as you are not having anything in urgent, I think you have our details also. You can call us, you can write us an email, you can find us through the webpage and ask your questions personally if you want to go back to your lunch. No problem there. Thank you very much. I don't know if my colleagues would like to say anything. I think everybody's on the line. Somebody would like to say something. Otherwise, I will just end the webinar for everybody. Thanks a lot, many thanks to Tarmo and Michael for the presentations. We really appreciate. We really love working with our customers. We learn so much more by working with you, and yeah, your presentations, your working days and your exciting projects are, we also take pride in your great projects. So thank you so much for being here today, and also great job. So thank you. I will end the webinar for everybody. Have a great afternoon. Enjoy your lunch, and I hope we speak soon, and maybe we can arrange a day like that next year also. Bye.